Hi students, welcome to the second lecture of the FPGA design flow. In the lecture 1, we have seen the VHDL code implementation for a given digital system. Right. After writing or developing the VHDL code for a digital system, we have simulated that VHDL code by using Xilinx Vivado. And we have seen the simulation result by using a waveform, and we have verified all the test cases are the truth table combinations for the given input, and we have seen the output combinations also. In the last lecture, we have seen logic gates operation implementation by using Xilinx Vivado. In this video, we will focusing on the synthesizing of this VHDL code for the logic gates by using Nexys 4 board, by using Nexys 4 DDR board. So this is the Nexys 4 board. The Xilinx company's Nexys 4 DDR board has RTX 7 processor. It has an RTX 7 processor, right? So let us continue the last session from the Xilinx Vivado, right? So in the last class, we have simulated the logic gates operation. So this is the last class. We have seen the program. So I'm maximizing this window and I'm pulling out, that is I'm floating, right? So this is the window. So in this window, we have seen the library files declaration, and here we have seen the use instruction for using a specific library module, that is IEEE.std underscore logic underscore 1164 module. Okay, after that, we have written the entity declaration. In the entity declaration, generally we are representing the input and output ports. Next, we have seen the architecture declaration in the VHDL code. In the architecture declaration, we have three models: data flow, behavioral, and structural model. We have written the code in the data flow style in this architecture. Okay, right. So this is the VHDL code implementation for the logic gates, and these are the simulated output results. So here I did again float for the waveforms. So we will see clearly the signal. So here, these two are the inputs. This is the A input and this is the B input. So the input A and B, we are representing 0-0 combination, 0-1 combination, 1-0 combination, and 1-1 combination. For all these input combinations, we have seen the output. This is the simulation result. Okay, right. So these are the issues we have already discussed in the last class. So for that reason, I am moving fast. The next step is generating an UCF file, that is user constraint file. Otherwise, we have to map the input and output ports, which we have defined in the VHDL code, to the Nexys 4 board. See here under the RTL analysis, you can see the open elaborated design. So click on this open elaborated design. Then it will ask you want to run or you want to perform. The current elaboration settings allow you to perform input output planning and constraint related work with the elaborated netlist. But the settings slow down netlist elaboration. Right here, we have to mention the input output pins which are available from the Nexys 4 board. These pins we have to map with the code written. We have written some code, VHDL code for the logic gates. These A and B pins we have to map with the hardware board. Right now, click on OK. So after click on OK, it will do some process, that is elaborating its design. So after elaborating design, 100% if it is over, then you can see a special window here. So it will take some time. We have to wait. So it is also loading the devices. which we have given as a target device as Nexus 4. So the Nexus 4 hardware device board pins and configurations are a loaded background when you are clicking the elaborated design. Now see here, in this, here we have our input output port section is there. In the input output port section, here we have the scalar ports option is there. In the scalar port options, we have the inputs A and B, and here we have the all the output combination. Here we have all the output combinations. Okay, and here one more thing, default generally defaultly it will select here default layout option. In the place of here you have to select IO planning. Okay, so if it is in the default layout option, you have to change that option, default layout, to input output planning. When you are selected input output planning, then only it will shows the scalar ports, otherwise it will not show. So see here, I am selecting default layout, then the scalar ports are not visible here. So when you are selecting input output planning only, it will display the all scalar ports information. In this all scalar ports information, now the task what we have to do, first you have to select the input and output standard technology, input and output standard technology. So here we are taking the standard technology as LV CMOS 33. This is the standard technology for our Nexus 4 board. These details you can drag out from the whichever the board you are using. So here I am selecting LV CMOS 33 board. Here also I am selecting LV CMOS 33 technology for all our input and output configuration. This is very, very important one. You have to select for all the pins. Don't leave any pin without selecting. If you did like that, your code maybe will not execute or synthesize in this hardware board. So all the input output ports you have to select as LV CMOS 33. Okay, so this is the first activity you have to do when you are generating user constraint file or when you are representing the input output ports. Now here I have two inputs called AB, and here I have 7 outputs: AND G, NAND G, NOR G, NOT G, RG, XNOR G, XOR G. So here Nexus 4 board has so many inputs like switches and so many LEDs here we have. If you see the manual of the Nexus 4 board, first go to the Google and type here Nexus Xilinx Nexus 4 DDR board PDF file. Search this name with this name, and you will get from the Xilinx website one PDF file. Click on this PDF file. You will get a PDF file. So download this file and open separately. Here I'm downloading this file into the desktop. Now I downloaded this one. Now I'm opening this file. So open this Nexus 4 board PDF file. Okay, right. So this is a Nexus 4 board, and this is the hardware kit available with us. And you have to come to down, right? This is the picture. So what is this Nexus 4 board and what are the components are available here? We have represented. Here we have the serial numbers from 1 to 20. Here we have serial number 1 to 24. Here the total 24 description, 24 items available in the Nexus 4. This is we have represented. So see here. So this is the first one. What is this first one? Power select jumper or battery header. This is a power select jumper or header. And here we have to see the two important things. The first one, the on and off button. So see here the number 23. So the number 23 is the very important one. Here I'm writing the number 23. Number 23 is the kit power on and off button. That is the first one we have to see. When you are going to switch on your kit, first you have to connect your USB cable with this hardware board. A USB cable will come. So USB data cable. That USB data cable you have to connect here for the pin number 2. For the pin number 2. So see here. Shared UART or JTAG or USB port. Okay, so this is the most important port. This is the very most important port, port 2. So you have the data cable with your kit. The USB connectivity you have to connect to PC, and the remaining connectivity, that is OTG connectivity, you have to connect here. That is at the place of part 2. This is a very important one. After connecting your data cable to here, you have to switch on the power supply. When you are switching on the power supply, it will automatically switch on the kit, and one default program will run. That I will show with a video. Okay, presently these two are very, very important. The next thing, here I am zooming. Here I'm zooming everything. See here. Here I have. These are the input pins. These are the input pins. These are the input pins. All these are the input pins. Totally here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Total 16 input pins are available. And LEDs. So see here, a small LED is available here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Total 17 LEDs are available. So for each, total 16 LEDs are available. 16 switches are available and 16 LEDs are available. You can see this is the LED. Right? This is the LED. This is the LED. Okay, so these are the LEDs are available. So you have to take this switch address and this LED address. You have to note down this switch address and this LED address. Here we have totally we have to use two inputs, that is AB. For that you have to take this V10 and U11. These two address pins we required here. I am writing these all are the things in your notepad file. So I am using switches. For A switch I am using V10. Okay, and for B switch I'm using V11. Okay, next I want 7 LEDs outputs, NOT gate, AND gate, OR gate. So see here, this is the first LED. Here I'm writing first LED address is V11, and second address V12, and third address that is U14. Next LED V15, next T16, next U14, next T15. Okay, these are the 7 LEDs I have taken. 1, 2, 3, 4, 5, 6, 7. Total 7 LEDs I have taken. Now I am minimizing this PDF file. Now I am opening my design again. So see here in this design, package pin option is there. Package pin option there. By clicking here the package pin, automatically it is showing the some pin numbers. Already we have noted down all these pins, right? Now I am writing all these pins. Okay, so see here package pin. Here we have to mention. So it is not coming full screen. Okay, no problem. So see here. First, I'm taking A is V10. For A signal, I'm taking V10 of the package pin number. So V10, I'm selected here. Automatically, it shows that number. Next, B input. B input is V11. So see here, this is the B input. Here we have to select V11, right? Next, AND gate output. Here I am taking first AND gate output. AND gate output, I want to give the first LED V11. So this is V11, right? Next, V11 is already over. Oh, wait. Oh, sorry. This is U11. B1 you have to give U11, right? So here first you have to type U11. It is over. Next, this is V11. Input terminals and output terminals are very, very carefully you have to represent. AND gate I have taken V11, and OR gate I'm taking here V12. And next NOT gate I'm taking U14. Next NAND gate I'm taking V15. Next XNOR gate are there, U14. Wait, NOR gate is V15 already we did, right? After V15 we have to take T16. Here you have to represent T16. Next U14 and your T15 is empty. Here we have to write down U14 Next, U14 already we have written. Again, we have to see this is U14 or V14. U14 already over. So U14. Okay, this is V14, not U14. This is V14. This is V14. V14, and this is U14. Next checks. Here we have to U14 over next. Here we have T15, last one. T15. So these are the ports we have to give, and now click on the save. So it will ask some file name. You can give anything, whatever you want. Next, click on OK. Now it is saving is over. Next, we have to the next process is we have to run synthesis process. So click on the run synthesis process. The synthesis processing starts the designing the runs. So see here in the right side top, you can see running synthesis design option is there. After running the synthesis, you have to start the implementation part. So in the PB in the slides we have seen. See, this is the design synthesis and implementation part. This design synthesis and simulation part we have to start. Here you can see right side top corner. This is the place you can see running the synthesis design. So after synthesizing the design over, then the next step is implementation part. Okay, so it will take some time to execute the synthesis process or implementation part. We have to wait up to that time. So after completion of the synthesis process, it will shows a pop-up. So here a pop-up window came. So it is showing that run implementation. So open synthesized design and view report. If you want to see the synthesized report, you have to click on the open. Now I don't want to see that one. I want to start the next process without making delay. Run implementation. Click on the implementation. In the implementation part, we have to place the components, place the gate level netlist file, which is generated at the end of the synthesis process. Actually, the synthesis process converts the high level language into gate level netlist file. So see here on the right side top, one, here you can see initializing design. In this place, running optimum design. That means the optimum circuit, the minimum number of inputs it will take automatically, the minimum number of outputs it will take, the minimum amount of power supply it will take, the minimum number of gates selections will be done by automatically, and the routing structure or placing structure, everything it will select automatically. After optimizing the design, it will start the routing the design. Placing and routing is the very, very important steps in the FPGA design process. So you have to carefully see here, right? So this is a very important one. So we have to wait up to completion of this routing design part. Okay. So after completion of implementation part, then we have to start next step, generating the bitstream file, which is used for downloading or uploading into the kit. We have to upload into the kit, right? So you have to wait for some more time. The placement, it will do fastly, but routing it will take some time. Okay, and this is the structure, right? The pop-up window came. Now select the generate bitstream file. We have to generate the next step. Then click on OK. I'm not making any delay. Now bitstream file is going to generating here. So up to this step, there is no necessity of the connecting the hardware. So your Nexus 4 board, there is no necessity of connecting up to this completion of this step. So after completion of generate bitstream, next step is here. You can see here in the downside. Here you can see open hardware manager. Here you have to open hardware manager. Okay, all right. So bitstream writing is doing here. The bitstream file is over. Automatically, it will suggest what is the next step we have to do. Okay, so we have to wait for the pop-up window. It will some time because of it will load all the hardware details, which will easily execute for us. Right. So completed the bitstream generation file completed. Then go with the open hardware manager. So this is the last step we are going to do here. Now click on the open hardware manager and click on OK. Click on first open hardware manager and click on OK. So we have the window, the pop-up window is closed. Now this hardware manager window we got here. See here, this is the hardware manager. It is showing, and here we have the console, and here we have the our basic program, logic gates 7 program. Now click on here open target. So whichever the target we have mentioned previously, that target we have to open and we have to connect it to the our PC. Okay, now open your kit, Nexys 4 board kit, which is available with you. Open that kit and you take the data cable and connect your kit to the PC. That is very, very important. So after connecting, you have to click on the auto connect option. Presently, I'm not connected any hardware with me. So for that reason, it is not showing any output device. Now I am opening my hardware and now I'm connecting here. After connecting the board to the my PC, it will come automatically. So see, now I connected my hardware board, Nexys 4 board. Now see here, after connecting, it is automatically pop-ups this information. So see here, hardware manager, it is automatically connected here. I will show this. Yeah, I'm dragging out here this window. So see here. So localhost Xilinx Digilant technology related hardware board is selected here. The board name is XC7A100T_0. This is the hardware details we have selected previously, and it is not programmed. That means we have not dumped any, we are not uploaded any code into this hardware kit. So there is no programming available presently in this kit. So the next step we have to give the right click on the hardware board. This is the XC7A100T board. You have to give right click and click on the program device. So it will shows a pop-up window after giving the program device. So when you are clicking on the program, automatically it uploads the code or bitstream file into the hardware board. So now I'm clicking on the program. So the programming part is done. Okay, now see the output. Hi everyone, this is the Digilant Nexys 4 DDR board. Now we have to connect this hardware kit to the our PC. So they provided a data cable. And one side of this data cable you have to connect it to the PC, right? So this is the PC. If you are not connected any hardware device, it will shows an error. Now here we have to connect the device. So here I am connecting this USB cable to my laptop, and now I am connecting this one to this hardware board. So see here, here we have represented, this is the data cable connectivity port, this is the our voltage cable, this is, seems to be like as our mobile charging point. Okay, next this is the power on and off button. Okay, let us see the connectivity. So here we have connected the board. so I'm switching off this kit. Now I'm switching on this kit. So now I switched on this kit. So after switching on, it automatically loads a default program. So the vendor design persons, they made a default program. So whenever you switch on the kit, so see here, these are the input LEDs. Here we have input switches, sorry, not LEDs, switches. So see here, so this is the input switches. If you are keeping all these pins, if you are keeping all these pins, input pins are in the off state, there is no programming for these LEDs. When you are switching on, automatically these LEDs are going to switch on, right? These are the LEDs. So they retain the default program for this switch. For the first switch, the first LED should glow. The second switch, now I switch off the second switch. So second LED is going to off. Now I am closing this third switch. The third LED is also automatically going to off. Like this, for each switch, they have a corresponding LED is available. That corresponding LED they made switched on. Okay. Now coming to here. This is the 7-segment LED displays, and here we have two multicolor LEDs. Here we have two multicolor LEDs, and this is the very important LED done. When you are dumping your program, it will shows busy. After completion of programming device, it will shows done. So these are the details about this hardware pins. Now I am doing the program. Okay, programming the device. Click on here. Okay, so here my hardware board is selected. See here, my hardware board is selected. Now click on this XC7A hardware board, then click on the program device. Right, it is showing some pop-up window. Are you ready to do the program? So this is the bitstream file it is showing. Then click on program here. So we have clicked on the program. So after programming, it is came. Right, so I'm keeping all switches in the off state. So here I have done. So see here we have to see first again I'm programming the device. You can use the reset button. So see here we have the reset button. Click on this reset button. What happened? So I am pressing the reset button. Okay, so this busy LED glows for a fraction of seconds, and after that it will shows the default program. Now I am showing this one. So see here, I have given right click and programming device option I have clicked here. Now I am clicking on the program. After clicking the program, what happens? You see, right, the default program stops automatically. After programming device, default programs stopped here. Now let us see the program which we have given, that is loaded here. Here we have the input pins AB. Okay, these first two switches are the AB pins. These two are the A and this is the B pin. See carefully here. These are the two input pins, the first pin and second pin. Okay, so this is the first pin and this is the second pin. Here we are representing, this is the first pin, this is the second pin, this is the pin A, pin B, and these are 7 LEDs we are using. Okay, so we know that the first LED we have written for the AND gate, right? So the first LED we have written for AND gate, and second LED we have written for the OR gate, and third LED we have written for the NOT gate, and next NAND gate, NOR gate, XOR gate, XNOR gate. These are the LEDs we have given for the output analysis purpose. So see here, first two switches I am keeping now in the position 1, logic 1. Automatically the AND gate output, so the first LED output it should glow 1. Okay, so see here I am keeping first switch 1, second switch 1. Okay, I have kept the first switch position and second switch position as 1 1. Right. So first switch position I have kept 1 and second switch position I have kept 1. Now the output LED also going to glow. So see here the difference. If I put the flashlight, it will not displays. So see here, first LED glows and second LED also going to glow. So see here the positions of the switch. These two are in the on position. The remaining switches all are in the off position. Only the first two switches are in the on positions. When A is equal to B is equal to 1, then AND gate output. So this is the first AND gate output. You can see the pin numbers also clearly, V11 and V12. These two LEDs are going to glow. Okay. Now again I'm offing the switch on of the flash. This is the activity happened. Okay, or both 1 we have given. So if any one of the input is 1, another one is the output is 0. So see here 0 1 combinations I have given here, 0 and 1 combinations here given. The first LED AND gate is going to off and the second LED is representing the OR gate. Any one of the input is 1, automatically OR gate output is the 1. This is the logic functionality we know. Okay, this is the synthesis process for the Nexys 4 board. Okay, with this we have completed the complete FPGA design flow. With this we have completed the complete FPGA design flow, right? So this is the programming device. So if you want to write any program, if you want to change any program, you can change here, right? If you want to change any program, you can change at this place, and again you have to do the synthesis process, again you have to do the implementation part, and again you have to do the generate bitstream file, and you have to do the again hardware manager you have to select, and you have to again program the device. All the steps you have to do again if you change your code as per your requirement. If you are not satisfied with the present input, you have to do the activity. Now I am doing the pressing the reset button. So I clicked on this reset button. Now the whatever the program we have written, that program is going to erased, and the new program, the default program is going to switched on. Okay, so this is about the complete representations or implementations of FPGA design by using Nexys 4 board. Okay, thank you very much.